Hi there, my name is Sven, and I work in the office of the CTO at Solace. We are the makers of the PubSub Plus event platform, which includes event brokers, event governance, observability, and many other things. And my personal main focus is on event APIs, AsyncAPI, and unified or federated API management. Today, I'm going to talk about lessons we need to learn from REST API design in order to create good async APIs. And I'll also talk a little bit about how we need to tie in REST documentation, how we need to tie our documentation in with REST documentation and developer portals. You might realize that I've narrowed down the original title from Sync APIs to REST APIs. There's two reasons for that. Number one, when people say APIs, they often actually mean REST APIs. They don't think about other API standards. And number two, it's actually down to LinkedIn post that I came across recently, and I'll get back to that post in a moment. So the last time I presented this API days, I went over my allotted time by quite a bit. So this time I decided to stick to three main points in an attempt to do better. And as we say in German, all good things come in threes. Alle guten Dinge sind drei. So there's three good things that I'm going to talk about that make a good async API. The first one is familiar documentation. So concepts are easier to understand if they are presented in familiar terms or in a familiar way. Second one we're going to talk about is consumer needs first. So someone is using our async API, we should serve their needs. And how do we do that? And the third one is consistency. What terms do we use? What do we align our channels and messages and our async API with? Now, while I've been speaking, you may have wondered about the background here. It's a medieval painting, and what's the back? Why is it there? Let me explain. I use this German idiom, alle guten Dinge sind drei, quite a lot. But I never really looked up what it actually means, so where it comes from. So it turns out it refers to a German folk and court assembly called a Ding or Thing, and there's the number three is significant in two ways for this, because number two, the court said 3 times a year, and if you were a defendant and you had to be summoned 3 times before you could actually be sentenced in your absence. So if you didn't turn up 3 times, you were actually you could be judged in your absence. So the third thing, that was actually a lucky day for court, not for the defendant. So why am I, like, when I read this, the LinkedIn post that I referred to earlier on, that made me refine the title of this presentation, kind of took on a different dimension. So let's look at that. So here's the API evangelist saying, like, in essence, like, he's still reserving judgment, but he thinks that in the future he'll go like with REST-style APIs and maybe a bit of webhooks, right? So I thought, like, if someone like who's dealt with APIs for years and years says something like that, it sounds a bit like Judgment Day for other API styles. So the good news is they're still withholding judgment. Bad news is actually what do we do about this? And when I read this, I kind of, like, with my background of, like, we do event brokers and we think event APIs are the right thing to do. So I kind of found myself agreeing with what Kin Lane was posting here. And then I didn't. So it left me kind of like this, right? So yes, but actually no. So what's the yes part of it? I think, like, successful APIs must be like RESTful APIs, right? Everyone knows REST APIs. People understand them. They can have tooling around this. They have, like, they know how to deal with REST APIs. So the closer we look to REST APIs, most probably the better. Why do I think no? Because technology matters. So if we're thinking about events, like, it is actually like there are aspects of, like, using a better protocol than REST to distribute events efficiently, which means, like, you have to come up with different technology solutions. And we actually, like, I talked about how as our customers kind of re-platformed their connected car APIs from REST to use other protocols like MQTT, and that's kind of like there was really benefit for them because it made them actually save a lot of money, and which means, like, less data volume, less money spent on data transfer fees, less money spent on technology along the way, right? And also less energy spent, right? So there's an environmental aspect of that as well. So that's where I disagree. We can't use HTTP for any API because it would just be too wasteful, right? So thinking back about the court, let's move on to the first topic that I wanted to talk about. So the court sits 3 times a year. And in order to actually be able to make your defense and not be judged in your absence, we need to be there, right? We as the AsyncAPI defendants, we need to be in the court. And the first step to do that is that's where familiar documentation style comes in. So can I, as a developer, view the documentation in the same place as REST APIs? So can I find async APIs where REST APIs are? Does it look similar to REST APIs? And so on, right? Luckily, we will see that the AsyncAPI folks have laid a good foundation for that with the specification and all the tooling around it, right? So to make it kind of like to be able for a developer to actually look at an async API and kind of understand a lot with the REST background. So just to kind of reiterate, like or put up kind of what I consider a not so great example is like, look at this GraphQL API reference on the left, look at the REST API on the right, there's API documentation on the right. I think that kind of makes the API evangelist's point. So I kind of agree with that, like what's easier to understand with your background as a developer, and what's the lower learning curve and so on. So that's really what we're thinking about here. And that's where GraphQL doesn't, like in this case, GraphQL doesn't come out that well, in my opinion. So luckily, as I said, the AsyncAPI initiative has done some really great things. So which makes AsyncAPI look so much better, right? It looks very similar to REST APIs. You've got channels, they're like resources, you've got a server section, you've got embedded schemas and so on. So there are a lot of things that are familiar to you if you're coming from the REST world. And these screenshots that I'm showing you here are from a developer portal that presents and provides access to both API styles and allows developers to actually also gain access to these APIs. So that means we're in the court, so we can at least make our defense, right? So we can make our case, and that's cool. Here's another example. A different developer portal, same thing really, like you can find REST APIs and async APIs in the same place. They actually, like, number one, again, like REST and async API looks very similar. And you also see, like, across these developer portals from 2 different vendors, they're actually using the same type of representation. So that's also kind of makes this case stronger. So moving on to the second thing. Consumer needs first. So how this is where we need to think about what the consumer expectation is. So and that means we need to think about how we can make our events easily understood, and how we think about what the developer would expect to, how they would expect to use our APIs with a REST background. So the first thing we need to do is, like, and this is kind of obvious in many ways because we're APIs, the word interface is already in there. Developers think in resources grouped into APIs, right? So and therefore they they don't need to actually have an understanding of whatever is behind the interface, right? Of the intricacies and the internal domain model. We just show them, like with REST APIs, we show them an interface that they can understand, that's easy enough for them to use, right? So the same applies to events. Like they will not have a good understanding of our internal event domain model and how it all hangs together, and even more because events are loosely coupled. They're kind of like looked at in kind of the traditional, like, messaging oriented middleware eventing world. They're going to look like more as discrete things rather than part of an interface. So what we need to do is group these related interfaces, related events into event APIs, and then manage the lifecycle of event APIs and not the discrete events. And that essentially is what Async API enables us to do. So we see an example of the messages section of an Async API that declares like 3 different events from our order domain, right? We group them into the orders API, and that's something from looking from the outside in, it's a lot easier to understand for me now, right? There is a danger that comes with this because, like, you could do something similar, like that's depicted here in the slide, right? You could just say, like, all our events, they arrive at the same topic. So we give like one channel or one topic to the developer, right? We call that the orders API, and we're done, right? The problem with that is this is kind of an anti-pattern, because as you can see in the Async API snippet on the right, you now have one channel that could contain any of these messages. So as a developer, I am not in charge. I'm not in control of what I'm going to receive. I'm going to kind of open a host pipe of events and and figure out like what it is out of that, like out of a large number of events, which ones am I interested in. So that also is a bit like contrary to how REST developers think, because they kind of like you do either get on an orders resource and you can apply filters, or you can actually get the state of an order directly by specifying its ID in something like a resource URL. So how do we fix that? We actually need to think in resource URLs, and we need to expose resource URLs. So here's an example of an order channel that has a couple of parameters in there. It has some data around like what kind of event is it that appears on this channel that's canceled. Then you have some parameters like the order ID. You have some other parameters in the channel that allow you maybe to filter if you want to. And that allows you to do things like this. So you can listen for all events for a specific order 1, 2, 3, 4. We use wildcards when we subscribe. Like this is like an example of how it would look like an MQTT. I'm not being really prescriptive about what protocol needs to be used, or there are multiple around, but it needs to be able to express these type of resource URLs and fine-grained channels. To also do things like the second example, where you can actually say, like, can you give me all constant orders from the B2C customer so I can get these and notify someone to follow up with the customers, for example, right? So that puts the developer in control of what they can receive. So now the third thing I want to talk about is consistency. So there's obviously, like, whenever you're designing APIs, you want to be consistent across your different APIs in terms of like the nouns, the channel, the patterns you use for your channels, how you use parameters, what kind of schemas you're using. So that's, of course, like if you have multiple async APIs and lots of events, that's what you want to do. But there's another dimension of that. So from a REST developer point of view, I might start out using a REST API that gives me access to orders. And then I get a new requirement that actually asks me can you actually send a push notification to an order, to a customer when an order state has changed, right? It's been changed to ship, right? So now I need to be able to actually listen to events and process them and show them to a user. It means I actually come from a REST API world, and I need to understand the async API world. So that's what I mean with consistency. How can we make this user experience from the different API styles that developers use? How can we make that consistent? And there's like 3 things I think we can do. First thing is reuse. So I've got an example here of an open API and on the top and an async API on the bottom, and the pattern will repeat itself on the next few slides, right? So if you look at the top example, an open API, we have declared a 200 response to someone asks for an order by ID, right? We get an application JSON payload back, and we get a specific or the response will be adhere to a specific schema, right? If we want to transform that or transfer that to the async API world, it would be advisable to use the same schema format. So we're using application JSON here as well, and to use the same payload, so we can, like, the user can actually understand, can transfer directly what they've done in the RESTful world when they did their first implementation of an application to the fact that they now need to get events, so they look and feel familiar, right? The second thing we need to do is align our terminology. So here's an example of a open API resource URL, right? And it actually has an order ID embedded in it, the parameter embedded in it, so you can actually get to exactly the right order ID that you're interested in. And we've aligned the channel name on the bottom to follow a very similar pattern. So we added a couple of things because not everything is exactly the same in async API as in REST, but we can get pretty close and we can use the same verbiage, the same nouns, and so on, right? And we can declare the parameters as well. So here we've got an order ID as well, right? So the third thing we can do if we align terminology, we also need to think about, it's already mentioned, the order ID is kind of the same. It's defined in the same way, but like going a step further, if you have like in the upper example, an open API resource that returns a lot of orders, You give people the ability to filter by order, by different parameters like the order type and the sales region, and you define them as strings, and they're in the query part of the HTTP requests URL, and so on, right? So how do we transfer that? We can, like, AsyncAPI allows us to do that, right? So if you look at the bottom example, we're using the same parameter names. We're using the same definitions for these parameter names. If there were enumerations for sales region, like east, west, north, south, for example, like we may want to reuse those enumerations and declare them in a similar way in both API styles. So if you take that and put it all together, you get this again, like presented nicely in a way that is that has a lot of similarities with REST APIs. In a structure that is very similar to REST API. We've got a server section. We know we can connect using MQTT, so that's different, of course, because we're not using HTTP, but we have operations that look like resource URLs. We know what we need to receive, what we need to publish in order to interact with the system that sits at the other end of that, or the systems that sit on the other end of the async API. We have all our parameters, and it's all our schemas defined in here. And we'll see that we also have, so we have all of that, and there are so many similarities to OpenAPI. So going over the 3 good things again. We talked about familiar documentation styles, so we need to be where REST APIs are, so we can be part of that world that developers are in, right? It needs to look familiar, and we've seen that AsyncAPI initiative has done, like, the great work that they've done is kind of what enables us to achieve this, right? We need to put consumer needs first from a REST developer point of view. Like, nobody's forcing me to use all the resources declared in an OpenAPI. I can pick and choose, and I'm in control of what data I retrieve, right? So they need to have the same level of control for async APIs. And then consistency between, like, how we define REST APIs and how do we define async APIs. So can we use for the channels parameters and messages? Can we reuse schemas? Can we reuse resource URL patterns in our channels? Can we use the same parameters and the same definition of parameters, right? So all of that put together kind of took us to that screenshot I just shown before, what the async API spec that looks so familiar and is so intuitive also to REST developers. So thanks for your attention today. Hope to see you soon again.